Okay, we're going to look at Lesson 31, Binomial Expansion. You have not probably done this, so it should have been done in Algebra 2 or in Pre-Calc, so in case you see it, I thought I'd go through it. Don't memorize the formula that's in the book. Look for patterns and organize your work. Now, Pascal discovered that if I have a binomial and I raise it to certain powers, he could create Pascal's triangle. So anything raised to the 0 power equals 1. And then whatever we have here, these coefficients are 1 and 1. So if you start off with this as the beginning of your triangle, you can find the coefficients of all the other ones and keep going. So they always start off with 1 and 1. So I put a 1 and a 1. Add these two together and I get the 2. Notice, exponent is 2 and I end up with 3 terms. So I put for this one here a 1 and a 1. 1 and 2 is 3. 2 and 1 is 3. So these are now the coefficients of this binomial expansion. And you can just keep building it. Now the problem with this is that this triangle gets bigger and bigger and you would have to keep doing this over and over and again. These are the coefficients of the terms. And notice there's one more term. This is the power of 6. There's 1, 2, 3, 4, 5, 6, 7 terms. Now, your best way to do this is to organize your expansion. You're going to actually write down what the terms are, what the exponents of the first one, the exponents of the second one, and what these coefficients are. Now, the coefficients, if you had just a small expansion, you could do the triangle, but if it gets to be a bigger one, it's much harder to do. And if you'll notice, there is a way to do it using factorials. It's the exponent of your binomial, so if it's a 6, it would be a 6 down here. The exponent of the first term factorial and the exponent of the second term factorial. So let's look at example 1. Write the first 4 terms. There's going to be 8 terms. I don't need all 8, I just need the first 4. So what I did is I wrote terms 1, 2, 3, and 4, and I put the exponent of the first term and the exponent of the second term. So, remember, it's a 7, so it's going to go 7, 6, 5, 4. And the second term is going to go 0, 1, 2, 3. Now, if I look at my coefficients, remember, it's whatever this exponent is, factorial on all of them, and then whatever these are in the denominator. So 7 factorial, 0 factorial, 6 factorial, 1 factorial, 5 factorial, 2 factorial, 4 factorial, 3 factorial. This organizes it so we can now find the 4 terms. So here's my coefficient. Here's the first one to the 7th power, delta x to the 0. Here's my second coefficient, x to the 6. Notice the 6. These two have to add up to 7 on every one of these. And so now I have my 4 terms. To find out what those numbers are, I'm going to put it in the calculator. And 7 factorial over 7 factorial, those cancel out, and 1 over 0 factorial is 1. Delta x to the 0 goes away, and so I end up with just x to the 7th. This ends up being 7. X to the 6, delta x to the 1. This value here ends up being 21. X to the 5th, delta x squared. Now this goes on, but they only wanted the first 4 terms. Now let's look at example 2. They want us to find the 8th term. I don't care about all the other ones, so don't create yourself more work. Now it is raised to a 12th power. So I just went terms like that, and I only want this one. So I know the exponent of the first one goes 12, 11, 10, 9, and it goes to 5. These two have to add up to 12. But I also know that it goes 0, 1, 2, 3, 4. Now that I know that, I can find the coefficient. This is a 12, so it's 12 factorial, 5 factorial over 7 factorial. That's the coefficient I'm going to have for the 8th term. So now let's see what I've got. I've got 12 factorial over 5 factorial divided by 7 factorial. The first term to the 5th power, the second term to the 7th power. And putting this in my calculator, I get 792. So there is your answer for the second example. Now let's look at the third. They want us to find the 10th term. Now this one's a little more complicated because these are more complicated. So what I'm going to do is my terms I know that I only need the 10th term, so I don't care about all the rest. So I know if that's a 10, that's what I'm looking for. And I go 15, 14 all the way down, that makes that a 6, which means that the exponent of the second term has to be 9, because 6 plus 9 is 15. Now to get my coefficient, it's going to be, 15, because that's what this exponent is, 15 factorial over 6 factorial, 9 factorial. Well, 15 factorial over 6 factorial, 9 factorial is the number 5005. Now this is my first term, so I go to my first one, 2x to the 6th, and it's raised to the 6th power. Then I come along and I take the second term, including the negative, and I raise it to the 9th power. Now looking here, negative with an odd exponent means the whole thing's going to be negative. And I can simplify this x to the 18th, and this is 2 to the 6th times this number. When I multiply these two numbers, I get a rather large term, or large coefficient, x to the 18th, y to the 9th, and I brought this negative in front. Alright, this last example has to do with finding out if certain general forms of equations are ellipses, hyperbolas, circles, or parabolas. We did this a little bit in pre-calc. So if I give you something like this, as long as there's not an xy multiplied together, then we know it's not rotated. We have an x squared and a y squared and a plus in front. So now it's either a circle or an ellipse. Because these two numbers are different, it has to be an ellipse. So we write down ellipse. In the next example, we look again, there are no xy's. When I say xy's, I mean x times y. There is an x squared, and I come along here and there's a y squared. Now there's a minus in front of here, so it cannot be an ellipse, it cannot be a circle, because it's x squared and y squared, it cannot be a parabola. So the only thing left is that it has to be a hyperbola. Now we're going to look at this one. There is no x squared. There's only a y squared. So our only choice is a parabola. Let's look at the next one. We do have an x squared and a y squared and a plus. So it's either an ellipse or it's a circle. Now remember, a circle is just a special ellipse. Now is the coefficient in front equal? Yes, they're both 1. So in this case, this is a circle. And that's all there is to 31.